The next lesson, review lesson, is going to be on exponents and power. So this here is what a power looks like, and there's the different parts of a power. So we've got a coefficient, a base, and exponent. This 2 here has nothing to do with the exponent 3, so this is just in front of this term. Therefore, the 2 is the coefficient. The base is whatever is on the bottom of where the little exponent is. So this a is on the bottom of this exponent 3. So our base is going to be a, and our exponent here is 3. When calculating powers and exponents, and we're using a calculator, you need to make sure you're finding the correct button. So I know with the iPhone calculator, if you turn it sideways, so this is the iPhone calculator, if you turn it sideways, you'll see a little x to the power of y. That is your exponent button. Or if you're using a calculator or any other type of phones, try to look for these here. The most common you'll see is usually something like this. You could also see this a lot. So for example, this, sometimes you can see like 2, and then you use this button, 2 to the power of 3. Something like that, that represents the exponent part. Now we're going to get into the rules that comes with the powers. So there's like multiplying powers, dividing powers. There's all different rules for them. So for multiplying powers, so when multiplying powers of the same base, so the key words here is same base. The base has to be the same. So remember, that's the part at the bottom of where the exponent is. So if they are the same, we're going to add the exponents. Okay, so for example, I've got 2, so my base is the 2 for both. I've got an exponent 3 and exponent 5. So what we do, since the base is the same and we're doing 2 to the power 3 multiplied 2 to the power 5, is we add them, the exponents together. So then we're going to have 1 base this time, and then we do 3 plus 5. So your final answer is 2 to the power 8. So you're going to do this whenever you are multiplying 2 powers together, but you have to make sure that the bases are the same. Okay, still working with multiplying powers. Here's another example. We're going to try to find the value of x. So we have 2 to the power of 3 times 2 to the power of x equals 2 to the power of 5. So our bases are the same. So when the bases are the same, then you're allowed to add the exponents together. So 2 to the power of 3 plus x will equal 2 to the power of 5. If the two bases are the same and we have an equal sign, we can just drop them down. So we have 3 plus x equals 5. Okay, you can rearrange this to solve for x, so bring 3 to the other side, so then it's going to be x equals 5 minus 3, x equals 2. Or you can simply just look up here and be like, 3 plus what can give me 5? So then the answer is 2, so then I'd be x equals 2. Now we're going to be dividing powers. So when dividing powers of the same base, again, keyword same base, subtract the exponents. So if I have 5 to the power of 4 divided by 5, if there is no exponent on a number, so that is my base, we don't see an exponent, that means there's an imaginary exponent of 1. But we don't actually need to write that or represent it. So if it's easier for you and you don't see an exponent, just put a 1 at the top. So what we're going to do, since the bases are the same, we can subtract them. So you have to make sure you're taking the first one. So this one here is my first, and you subtract the second. So I've got 5 to the power of 4 minus 1, giving me 5 to the power of 3. Okay, and then another example, we're going to find the value of x. So when I have 2 to the power of 9 divided by 2 to the power of x, I get 2 to the power of 5. So since it's division, we do subtraction. And because the bases are the same, I'm going to go 2 to the power of 9 minus x, and that's going to give me 2 to the power of 5. So what value of x can I put in so that 9 minus it's going to give me 5? So what you can do is write 9 minus x equals 5. Bring your x to this side, bring your 5 to that side, so that x is going to be equaling 9 minus 5, therefore it's 4. Or you can simply just look here and be like 9 minus 4 is what gives you 5. So our x value here is equal to 4. When finding the power, so now we're doing a power of a power. So when finding the power of a power, multiply the exponents. So in this case, there's only one base. The difference is that here's your base, and there's the exponent, and so there's your exponent, and then you have another exponent on the outside of the brackets. So you take those two numbers and you multiply them together. So for this example, we only have one base and we have two exponents. So therefore, if you have one base, two exponents, we're going to be using multiplying those two together. So we've got 4 to the power of 3 times 2. That will give me 4 to the power of 6. And that's your answer for this example. Okay, and then the next example, we're going to find the value of x, where 2 to the power of 3 to a power of x is going to equal 2 to the power of 6. So since we have one base and two exponents, we're going to multiply our exponents together. So 2 times 3 multiplied by x is going to give me 2 to the power of 6. Okay, so we can just look at it here and be like, well, what times 3 equals 6? And we know that x is equal to 2. If you want to be doing the rearranging, we have 3x, so 3 times 3 times x equals 6. I need to divide this side by 3, divide this side by 3. So since we were trying to get rid of it on the left side, I got to divide both sides by 3. That will cancel these out. 6 divided by 3, therefore x equals 2. So our value of x here is 2. Okay, and then we have negative powers. So what negative powers do, so if I have x to the power of negative any type of number, so what we do is we just flip it. It's going to be the reciprocal. So for example, if I have 3 to the power of negative 4, when I say to flip it, what we're going to do is we're going to put it at the bottom of a fraction, and we're just simply going to put 1 at the top. So now I'm going to have 1 over 3 to the power, and then we just change it to a positive sign, so 3 to the power 4. We can do the same with this one, so we flip the fraction so that I have 3 now over 2, and then it's going to be a positive 1 on the outside. Okay, and then I have this one here. So since it's a negative exponent, I'm going to flip the fraction. So I'm going to have 5 over 1 to the power of 4. But when anything is over 1, we can make that 1 imaginary. And we can just write this as 5 to the power of 4. And then the last one is going to be 0 power. So any base to the power of 0 makes the whole package equal to 1. So if I have x to the power of 0, it's going to equal 1. So for this example, we have my base of 432 to the power of 0. This is going to equal to 1. So now the package is only what your base is. So my base for b is negative 5. So negative 5 to 0 to the power of 0 is going to be 1. And then for c, my base here is only the 4. The negative kind of sits on the outside of it. So we're going to leave the negative on the outside here, and now 4 to the power of 0 is 1. So our final answer ends up being negative 1. So the difference between these two is that this one here is in brackets. When it's in brackets with the exponent on the outside, we have to make sure that the negative 5 is part of that base package. If it doesn't have, let's erase. Oops. So if it has doesn't have the brackets around the negative 4, therefore it's only the 0 is only with the 4 and not the negative. So we're just going to drop the negative in front of our final answer.